Hello everyone, this is the third video of the Fluid Simulator series. In this I will explain the settings of the Fluid Simulator for grid and curve as well as for Fluid Simulator for mesh. In my previous video I have shown how to use this as asset. Before we start, I would like to mention is that most of the settings have tooltips. So if you hover your mouse over the setting, it will show up. However, you can also read in-depth explanation of these settings from the documentations of these fluid simulators. So now let's get started. This is the fluid simulator for grid and curve. This modifier contains this node setup. It has the forces and velocity setter nodes, fluid simulator node, and particle and vector node. The settings of these fluid simulators are divided into different categories, like we have the grid curve settings, initial settings, and dynamic settings. The grid curve settings are particular for this fluid simulator. The initial settings and the dynamic settings are similar for both the fluid simulators. Okay, so now let's focus on the grid curve settings. The first setting is grid or curve. Basically, you want this fluid simulation on a grid or a curve based grid. You can switch between them from the modifier panel, or you can switch from this link. Okay, so let's connect that back to the panel. Let's switch this to a grid. So the first you have the grid settings. Let me hide these particles. Now let's focus on this. So if we go to the wireframe, the grid step is basically the resolution of the grid, and then you have the length of this grid and width of the grid, which are pretty standard settings. And after that you have the curve settings. You can input the curve from these nodes, or you can also input the curve from external object. Like in this case we are using this Bezier curve. So if we switch back to the curve, we have this kind of grid. Okay, the first setting is the curve step, which is basically the resolution of the curve based grid. Then you can define the radius for this. Okay, next is the curve profile settings. By default you have line or circle profile option, so you can switch between the line or circle. This is the grid based on the line profile, and if I switch to circle, we have this kind of grid. Okay, so here you can basically offset the x-axis with respect to the curve, y, and you can also change the angle for this profile. These settings are only for the default profile. However, you can also input the custom profile. So first you have to enable this, and then you have to add the profile. So let's add a arc. Radius pretty high. Let me make this 0.1. If I make this sweep angle small, something like this, run the simulation, see it is perfectly working. Okay, you can use any curve profile for the curve based grid. Okay, let's back to the default. In the end you have these two settings. The first is show geometry. So basically it's going to show the geometry which will be used to simulate the fluid. So it help you to debug any problem. Okay, after that you have the UVMap size. It can generate the UVMap one by one grid, or based on the length and width of this grid, or length and radius of the curve. So this is really important. Suppose if you want to use image texture for initial color or something, so for that you need a proper UV map. So you can use this option according to your need. Next we have the initial setting and dynamic settings. These settings are similar for both the fluid simulators. So let's focus on the initial setting. First we have the fluid solver option. We can choose between the fast or exact. Fast is based on the approximate method, and exact is based on the actual fluid physics. Settings which have suffix C are only for the exact solvers, and the settings which have suffix F are only for the fast solver. The settings which don't have any kind of suffix are meant to be for both the solvers. So here is the comparison between the fast and exact solver. Next we have the start frame or end frame. Basically we can define from which frame the simulation start or end. Like in this case the simulation will stop after 50th frame. See, So this is a really nice setting to start or end the simulation for a particular duration. Next we have the time step. This is really important parameter. If you set it to a small value, then fluid motion will be a slow but more accurate. However, if you set to a large value, then fluid motion be a fast. And if you set to a very large value, then fluid may be unstable. So let me show you this. Next we have the iteration for pressure. So maximum you have 20 iterations, and more the number of iteration, more will be the accurate pressure calculation for the fluid. Okay, so you can increase this value if your mesh or the curve based mesh is really complicated. Next you have the color conservation settings. You can conserve the color based on their individual channels, or you can conserve the color value. If you set this factor to a 1, then it's going to conserve the color 100%, or if you set this to a 0, then it's not going to conserve the color. So you can play with this factor to get a different result. So here is the comparison with color and without color conservation. And after that we have the boundary settings. For fluid we have to define the boundary. You have three options: open, closed, and in the closed you have wrap and solid. Let's set this to a open case, and you will see this the fluid will go out from this mesh. See, it is not coming back from this boundary of this mesh. So if I rerun this, next we going to use the closed option, and in the closed we have wrap and solid. So let's use this wrap. You can wrap the individual channel basically along the x-axis or the y-axis. If you have a curve, then basically along the length of the curve and perpendicular to the curve. Okay, so now if I run this, see, this color is mapped to this side, and you will see this color is basically mapped to this side. See, we have this color here. And if we use the solid is basically a wall, then fluid going to collide with the boundary. So it is bouncing back and coming toward the center of this mesh. This is the difference between different boundary conditions. Next we have the initial color and initial velocity. So right now we are using this checker texture. See, you can use any kind of color here. You can even use the image texture. So let's add an image texture here, and let's add the image texture. So we have this image of parrot, and here we can define the UV map. So let's add the UV map. Okay, now if I run the simulation, it's going to basically simulate these colors like a fluid. If I rerun this, see, these colors are moving like a fluid. The resolution is not that good. It can be better if we increase the resolution of our grid. Let's use 0.1. So it is more clear. You can increase according to your project. This is same true for the mesh fluid simulator. If you want a more detailed fluid, you have to increase the resolution of your mesh. Let me disconnect this and connect this to the color. Next, you can define the initial velocity. See, fluid is moving in this direction. So you can set up the initial velocity if you need. Now we have the dynamic settings. Dynamic settings are two types. These are the internal dynamic settings, and after this arrow we have the external dynamic settings. Okay. The first dynamic setting is the damp factor, which is basically like a viscosity. If you increase this, the fluid going to be slow down. So let me run this without this damp factor. And if I rerun this, see this fluid is moving. Now if I make this 0.2, see it is almost stationary, slightly moving. So here is the comparison with and without damp factor. And one important thing is that most of the important settings are based on the field. So you can use any kind of field to define this setting. Like we can define a region where the viscosity is high or low, then fluid will move accordingly. Okay. Like you can use a noise texture to define the damping. And next we have this velocity max, which is basically the CFL condition. It is similar as we have the fluid simulator in Blender. Basically this setting makes the fluid stable. A fluid can have this maximum velocity, so you can change or set according to your project. And if the velocity is going to be higher than this value, then the solver going to clip the velocity to this value. After that you have the option to smooth the velocity. This is important setting when your mesh is really complicated or your grid based on the curve is really complicated. You can basically slightly smooth the velocity to make the fluid simulation stable or more like a smooth kind of flow. You can use these settings. So here is the comparison with and without velocity smooth. After that you have the vorticity confinement option. This is only for the exact solver. So it's going to confine the vortex of the fluid and make the fluid more turbulent. So let me show you this. If I make this really strong and run the simulation, you will see that we're going to have more turbulent pattern. See, it is appearing here. So you can use this option to make the fluid more turbulent. And it also has this vorticity smooth option. Again, if your mesh is really complicated, you can basically smooth these turbulent. After that we have this color fadeness setting. With this setting we can fade the fluid color into any kind of color. So let's set this to be a different color, maybe this kind of pink color. And if I make this 0.1, you will see the whole color change to a pink. This is really a nice feature because sometimes you need effect based on the color that appear and disappear after some time. You can use this kind of feature to do that. You can even fade this to next we have the external dynamic settings. So there are three main settings: color, velocity and force. All these three have common inputs. In the color, first you have to enable this if you want to use this. Next you can define the color selection. Suppose if you want to update the color only a particular region, you can define this selection. By default this selection is true for the whole grid or whole mesh. You can use even a factor to control that region. Like in this case I am using this fall off node to only add the color near to this object. Okay. And it has different mode to set the color. You can mix, color, hue or saturation. You can choose any of the mode by changing the index. Okay. And here you have to input the color. Like if we set this to orange, you will see we are basically adding orange. Here we can also change dynamically the color of this. And next we have the velocity. Again you have to enable this option. Then you can define a reset velocity region using this selection, or you can use a factor to update the velocity. Right now we are only updating the velocity of the grid points which are near to this object. Okay, let me show you this. See, the points which are white are getting the velocity from this object. Okay, So here you can add the velocity from the object, or you can add the velocity from the noise, or you can also define your own velocity node to add the velocity of the fluid. Okay. Next we have the force. So to add the force, first we have to enable this. Right now we are using this turbulence force. Here we can also define the region for the force, or we can also control the force with this vector. And you will see this, it is adding this motion in the fluid based on the turbulence. See, this is it about the settings of fluid simulator for grid and curve. Now I will show you the settings of the fluid simulator for mesh. This is the node setup for a fluid simulator for mesh. All these settings of this fluid simulator are similar to the previous one except few settings. Like if you use the exact solver, in this case you have option to enable exact pressure calculation. So this is a really important setting when you are simulating the fluid on a very complicated mesh, then you have to enable this. Okay, but it's going to cause some more computation. Another different setting is the boundary condition. In this case you're going to define the boundary using the boundary attribute. So how to do that? So if I select this and go to the edit mode, and then you go to this data tab, and in the attribute you have to create an attribute based on the edge domain, and it's going to be boolean. So we have this boundary attribute. Next you have to select the boundary, like in this case I have selected these edges, and then go to mesh, then set attribute, and here you have to enable this boundary attribute. And after that you have to basically define this attribute here in the name of the boundary attribute. So this is slightly different from the previous fluid simulator. Another setting is this keep original geometry. If you are using a geometry that has a mixed type of faces like quads, triangles, then this fluid solver convert that mesh into a different kind of mesh to simulate the fluid. However, if you want to keep your original geometry, you can enable this option. Rest of the settings are similar as I explained earlier. So this is it about the settings of these fluid simulators. In the next I will explain the settings of the particulate vector and the settings of these nodes and how to use them. This is it. See you in the next video. Happy noding. Bye.